So before I get into the meat of the talk and introduce myself and all that other stuff, I just want to do this. We are on an aircraft carrier, people. And also in true George Bush fashion, I put this up ahead of the actual talk, right? So who am I? I'm Paul Dix. I'm the co-founder and CTO of InfluxData. I am also a New York City resident. I've lived here for 12 years. This is my yesterday was actually my first time on the Intrepid, despite the fact that I've been here so long. So yes, we're headquartered in San Francisco, but I live here because I am Big E, and my co-founder is Tupac. So I own the East Coast. Okay, so what's InfluxCloud? It's a managed service that we run for customers. It's single tenant hosting of clusters of InfluxDB. We also offer Grafana hosting and Kapacitor hosting as well. So before I get into all those pieces, the key thing that I want to focus on this talk is monitoring our infrastructure and what it would cost and also how we do it. So the thing is, if you look at SaaS monitoring providers, their business model is like totally insane, right? It's like $15 per host per month. So for us to monitor our infrastructure, which is fairly modest, would cost like $10,000 a month, which is just totally insane. Like we're not writing that check. So instead of paying 10 grand a month to some SaaS provider, we do it for about $700 a month, right? The cost of an EC2 instance to run InfluxDB and Kapacitor and Grafana and then collect all the data. And we get all the visibility we need using this setup. So just out of curiosity, raise your hand if you use InfluxDB. Okay, cool. Raise your hand if you use Telegraph. Couple, all right. Raise your hand if you use Kapacitor. All right. All right. More than I thought. So I'll intro those in a second. But I guess one question I have is how many people are familiar with InfluxDB? Know the data model and know the pieces. OK, so mostly everybody. So I guess I can skip the intro piece, which is why I said optional. So time series data, stock trades and quotes, blah, blah, blah. I guess this is one thing that I think is really important for InfluxDB because you don't see it in other time series databases, is we store regular time series as well as irregular time series. And we allow you to induce a regular series from an irregular one at query time by saying, give me 10-minute summaries of the mean over a 4-hour period. So the data model, just to remind everybody, measurement, tags. Tags are always strings. It's key value pairs. And then you have fields. You can have an unlimited number of fields. And then field types can be int, float, bool, string. And field that we don't care about. And then finally, a nanosecond epoch. It doesn't have to be a nanosecond. We store based on the precision that you ask for. And we also use variable compression depending on what the timestamps look like. So in the best case, for instance, if you have a regular time series where you're taking samples once every 10 seconds, we can use run length encoding to just encode 1,000 timestamps using 16 bytes, right? The start time and the delta. And actually not even 16 bytes, less than that, right? Because it'd be 8 bytes for the start time and then whatever you need to represent 10-second difference. So this is our setup. We run on AWS. We run in multiple regions. And we run clusters for people, as I said. So we deploy Telegraph on every single one of our hosts. And we have this for collecting system metrics, so like CPU, memory, hard drive, network. And we also use it to collect InfluxDB metrics. So Telegraph has an InfluxDB plugin where it will actually pull your InfluxDB server to pull in stats about its health. And we wrote that specifically for this. We have an InfluxDB server. Our monitoring stuff actually predates when we were offering clustering. So right now it's just a single instance running an M4 or 4XL, which is not bad. And then finally we have Kapacitor, which runs on the same host as InfluxDB. So the data flow looks kind of like this, right? So here, I'm just going to move around a bit. So here, InfluxDB, Telegraph, and System, that's on every single host, on hundreds of hosts in AWS. Telegraph collects the data. It sends it to InfluxDB. InfluxDB sends all of the data to Kapacitor in real time. And then Kapacitor does monitoring, transformations of the data, and it will occasionally send alerts to either Slack or PagerDuty. I weighted the line to Slack a little bit heavier because we have a specific channel for monitoring. It's just like the monitoring channel in Slack. And we favor more noise rather than less for that channel so that we can get more visibility. And then obviously for PagerDuty, somebody is actually going to have to get up and do something, so we do that less frequently. And obviously we use Grafana. I'll actually talk about this dashboard. I'll bring up the actual live version here at the end of the talk and talk a little bit about some of the stats that we collect and that specific graph. So Grafana is awesome. We use it. We know that most of our users use it. And Grafana is great for visibility. But visibility is only one part of the monitoring story, right? We have hundreds or even thousands of time series per server that we're looking into. So for us, we're talking about maybe 1 million total unique time series, and you can't visualize all that, right? You can't get insight from that. So really what you need is a system to monitor all of that, ideally in real time, and alert you when something is off or could be off so that you can do investigation into the problem, right? You need to narrow your search space, so instead of looking at 1 million time series, you're looking at a few dozen. So we use Kapacitor for that. So Kapacitor, I call a time series like processing engine. You can use it for monitoring and alerting, but you can also use it for ETL. You can use it for transformations. Quick info about Kapacitor in case you don't know about it. It's open source. We created it. We had the first release last November, towards the end of the month. So it's just over a year old. It's MIT licensed. It's written in Go. We created a DSL for it called TickScript, and I have some examples a little bit later. And there are integrations built into it to send alerts to a log file, a webhook, email, exec, so you could actually execute code based on some alert condition, Sensu, HipChat, all this other stuff. So Kapacitor is actually not just a real-time monitoring and alerting system. So it does stream processing, right? So it'll look at the real-time stream of time series data as it comes in, and you can trigger alerts based on that. But it can also do batch processing, which is useful if you want to do a comparison versus some historical data that you can't actually fit in memory, right? So something gets triggered, you want to query the database, or you want to periodically query the database for something, or query some other service. So now I'm just going to go through some of our scripts here. So this is all TickScript code and some examples of some things we do in our own system. So a really basic one, detect if a system is down, right? We haven't received any data from it. So here at the top, the period of time we're going to be looking at is 2 minutes. And we're going to do this check every 30 seconds. Can people see that? Oh, yeah, you can actually see that. We're going to select the stream. So stream here is a keyword in Kapacitor that says this is going to be a stream of data. We're going to expect incoming data all the time, and this is always going to run. Right? We're going to get it from the database Telegraph. We're going to look at the system measurement. Here we're actually filtering down what hosts we're looking at. So where lambda hosts equals regex. So we're only going to look at hosts that match those regexes. And then we're going to group by the host in the cluster ID. So basically group by host. Cluster ID is our own internal thing. Basically we give each cluster that we run for a customer a unique identifier. We don't need to group by the cluster ID, but we use that later if we trigger an alert so that we can send that information down. Host is really the only thing that's required. And what that means is group by host, we're going to have a separate stream of data that we're examining per host in our infrastructure. And then the windowing just says every 30 seconds, output 2 minutes worth of data, the last 2 minutes worth of data, right? So it'll do that every 30 seconds. So it means you're you're taking like slices that are overlapping in time, and you're evaluating those slices for the error conditions. So I pulled the message piece out as a separate like variable. I don't actually know if you can do this in TickScript. I think you can, but the message is basically just what we send if we have some sort of error. So there we see we pull in the host, so that goes through, and then we can say, oh, if the level's okay, then say that, else say it's back online. So basically you can see that we also track state changes of the alert state, right? We check when it's triggered, and we check when it's actually back to a normal state. So here we say where the host is not equal to 0, so we only care if there's actually a host there. Dead man is a keyword, so we call it a dead man switch, right? A dead man switch is basically like you're holding the thing, and if somebody kills you, then you let go of the thing and you explode or whatever, or something happens. So basically it just says the ID we don't need to look at, the message we put in, we only look at state changes, right? So this check happens every 30 seconds. If we stop receiving data, what it's going to do is it'll trigger the alert once, but then when it checks again in 30 seconds, if it still doesn't see data, it won't trigger it again, which is nice, right? You won't continually get the same alert over and over again. And in this case, what we're doing is we're doing a webhook. We're posting this somewhere. So here's another useful one. I'm sure most people who have run stuff in production have at some point or another had a system outage because their disks filled up, right? Could be your logs, could be your database. Most likely it's your logs. So this one basically will send us an alert if the disks are a certain percentage full. So here in this example, we're using crit, like a critical type alert, but we also have warn level as well. So the threshold is 80%. The period is every 10 minutes. We'll look for it. We'll check it once a minute. Here we can see we're using the batch style. So essentially what this does is instead of getting a constant stream of data, once a minute it will wake up and query the database using this query. So the used percentage from Telegraph, match only specific hosts, match only a specific path, right? Because we don't care about every volume on the server. And then group by the host, right? So we want to look at it for each individual host. Then if that matches, basically, so the first part, the query part, and basically that selects the data. Then we pipe it to alert. So basically any data that is selected will get piped to the alert node. So in theory, if everything's good, the alert node will get no data. But if something is off, the alert node will get data. We'll send a critical alert message, and we'll send it to Slack in this case. So this one is a little bit more complicated. It actually took a couple of slides. This is basically alert when the percentage of writes is too high compared to the number of requests that we're getting, right? So the error threshold here is 80%. 80 seems high. So the period is 2 minutes, 30 seconds. Check every 30 seconds. We're grabbing the stream from, again, group by host. The windowing, again, like we're looking at separate windows of time. We use the derivative. In this case, so InfluxDB has derivative in its query language. But Kapacitor actually wrote its own implementation of derivative for this stream processing system. So first we say we want non-negative derivative, all right? And if a counter gets reset, we don't care, we ignore that, right? And we pass in the unit, right? So we're looking at that period, which is once every 2 minutes. And then we evaluate this derivative as a derivative, finally. So this is the error delta right here. This is just calculating the error rate, right? This is calculating the request rate, the OK rate, right? So we have a stream again. We're assigning it to the OK delta. We have the from, we have the group by, the window. We have a default set just in case. We take the derivative again. So now we have the error rate and the OK rate, and we can combine them together to figure out what our error percentage is based on that. So we join the two together. We eval this expression, right? The error derivative divided by the error derivative plus the OK derivative times 100, and we evaluate that as the error percent. Finally, we pipe that to alert. And alert evaluates it and only issues a critical alert if that error percent is greater than or equal to the error threshold. And then again, only the state changes. And finally, we pipe it out to Slack. So the last thing that's interesting about Kapacitor, we haven't deployed this yet. As I mentioned, there are spots where we're grabbing cluster ID. Cluster ID is like a completely nonsensical thing. It's just like a random string, right? So what we're in the process of doing right now is creating user-defined functions to fill in more data. So a UDF is, in Kapacitor, there's a way that you can write code in any language. As long as you can speak over a socket, protobufs, then you can have a process that runs on your server. The Kapacitor will pipe data to and read data from, so it can transform it. We have libraries for Go and for Python that already exist, and we have examples up on the website for how to do things in Python. So the canonical example that we have for UDFs is actually to do like machine learning stuff, right? You can implement any sort of anomaly detection algorithm you want to do and that kind of stuff. But what we're going to be using it for in our own infrastructure is we're going to inject a customer name as a tag into our data stream. So that way, later on, when we get alerts, we'll get the cluster ID, but we'll also get the customer name so we can know immediately, like, oh, foo customer has this problem, right? Which is nice because then we don't actually have to like go to some other management console to look up a cluster ID to see who it is. All right. So I'm going to show a couple of Grafana dashboards that we have up and running. It's probably a bit more interesting for people who are actually running InfluxDB. So these are stats that we're tracking from InfluxDB, and this is a dashboard that we made for it, right? So here we have our specific cluster that we're looking at. We can see the disk utilization. If you run a cluster of InfluxDB, hinted handoff queue is actually it's kind of the canary in the coal mine for whether or not your cluster is actually doing well. If it's non-zero or non-1 rather, then you could be having problems. So this spike right here, we were doing an upgrade of this customer, and it was a particularly gnarly upgrade where things took a while to start back up, and you can see the hinted handoff queue really built up, but then we saw it like go back down, and everything was golden again. So we also have some other stuff here, like the CPU utilization and memory usage of the container, query duration over time, active queries, the number of write point requests a second coming in, write requests. Write errors is also another interesting one. So obviously you can see a bunch of spikes in the write errors. Like while it was replaying the hinted handoff queue, it started returning some 500s for some of the write requests because it was overloaded. But then as everything like normalized, we can see it goes back down to 0, which is nice. And then system load and all this other stuff. Measurement count and series count we also do. And finally, like the GC and the heap stats. So there's that one. So this one is basically our dashboard to look at the health of the monitoring instance. So it's kind of like the who's watching the watcher kind of thing. So again, just all these stats that we pull from both from Telegraph system stats and also from InfluxDB. So we can see like the requests coming in, the number of connections, the write points per second, the wall cache, how big that is, all that kind of stuff. All right, so this one is a specific like cluster view page. So we can see the system load, the disk utilization. This one is actually really important, the series cardinality. We track that because that has a direct impact on the memory utilization of the box. And unfortunately, in a single tenant system, we kind of have to expose to people what the size of the instances are that they're running. And most of the people who sign up for the absolute smallest thing. And then, of course, they throw gobs of traffic and data at it, and they complain when the thing falls over. It's, well, you can't run much on a T2 Nano person. So we track this so that we can immediately, if a customer is having problems, we can immediately go here and be like, oh, well, you're having a problem because you're trying to track 2 million unique series on a tiny, tiny machine. And then all the other stuff. So here we can see it's actually a cluster, the per host point throughput, right? So it's 2 different lines. So we run, the default clusters in our cloud are 2 data nodes, which are the ones that receive both queries and writes. So we can see those coming in. And then finally, the TSM compactions, which is, again, another interesting stat to track. So the storage engine in InfluxDB is one that we built from scratch, and it's inspired heavily by LevelDB. And like LevelDB, it will compact data files in the background as writes and queries are coming in. The reason that's important, well, 2 reasons that's important. One is when it's compacting, when it's doing a write, it will use more disk I/O, right? It's an append-only write, so it's not that bad, but it will definitely use more disk I/O. And the other key thing is the TSM files are actually read-only files. So when it does a compaction, it will take 2 or 3 TSM files, combine them together into one file. And the reason it does this is for compression and also for performance when doing range scans on series. But it'll compress it into a new file. So what that means is you need to have some wiggle room in your hard drive space in order for compactions to run. If you get up to 90% hard drive full and a huge compaction runs, you may actually run out of disk space in a second. So, and then finally, just another view of a cluster, which is this is primarily focused on the hinted handoff queue depth. Again, this is only relevant for clustering stuff, but again, the hinted handoff queue is the bellwether for how things are going in the cluster. So that is all I have. So questions, anyone? Yeah, so the question was, what was the TickScript DSL based on? It sort of looks like JavaScript, sort of looks like Python. That's no accident. When we started the project, so the primary author of Kapacitor is Nathaniel Cook. And when we brought him on board, I worked with him to design the initial cut of the TickScript language. And I think the functional style is very good for processing time series data. I've actually said this before. I hate SQL for time series data. I think it's a dumpster fire. So I like the functional style. And I also liked, in D3, the function chaining syntax that it has. So we wanted something that looked kind of like that. And that was the inspiration for the TickScript stuff. And why does it look like Python? Nathaniel's a big-time Python guy. So, yeah. Yep. Do we publish the dashboards for monitoring the Influx instances? No, we do not. Those are internal only right now. But we are in the process of capturing some specific useful data. And what we're doing is we're actually going to have Telegraph write 2 ways. One is to our monitoring instance for our own monitoring, and the other is to the customer's own database, some stats from the server that are useful. Now, for the InfluxDB stats, there's a database on every system called _internal that tracks a bunch of internal statistics like hinted handoff queue and all that kind of stuff. Was that one of the main features we're going to be working on? Yeah. Okay. So 1.1 just dropped earlier in November 14th. 1.2 should come out in mid-January, I think. So there are a couple of things for that. There's a limited kind of subquery functionality. So the biggest one I think that people will get out of that is cumulative sum. But honestly, the biggest feature is right now the database is the raw time series data storage, and there's an inverted index that's in memory. And when you start up, it reconstitutes this in-memory index based off of the raw time series data storage. So unfortunately for people that have massive, massive databases, it means their startup time can be pretty slow. It depends on your server because it paralyzes that. But so what we're doing right now is we're in the process of creating basically a combination of in-memory and disk-backed inverted index that's specific for our data model. So the structure of it looks very similar to the TSM engine. There's a write-ahead log that you append data to. It keeps stuff in memory. It flushes that out occasionally into an index file. And there's a compactor that will combine index files on the fly. So basically, it'll create a separate index per shard of data that you have. And what that means is if you have ephemeral series, they won't take up memory, right? So we memory map all those files, and we just let the operating system decide like what to cache. So the key win that we think is going to come from this is that you'll be able to put things like process ID or container ID as a tag, and it won't, like, those are all like very, very ephemeral, but over time it won't matter, right? You can have a billion unique time series, and we won't care because the only thing that matters is the working set that you're actually querying. That is a good question. I don't know if there is one. I don't know. I think the reason we did it using Telegraph is because we didn't want to, we actually can't query the customer database. Like, we don't have their password. So we can't query customer data. So we can actually hit the InfluxDB instance to query the, so we could, I mean, if we had access to query customer data, we could query the internal database and just get the same stats. But because we can't do that, we actually have to hit the endpoint to get things, so. Yeah, so the question is, did we do any scalability testing of Kapacitor to see how many hosts or containers we can scale to? Yes, we've done scalability testing of Kapacitor. The scale depends, it's wildly dependent on what you're doing, right? If you have one tick script that's fairly simple, it will be very, very scalable, right? You can easily handle, 300,000 values a second, 400,000 values a second, depending on the size of the machine. But if you have 100 tick scripts that are defined and they have all sorts of complexity to them, you're going to get a lot less out of it. So at some point next year, ideally, we will have a clustered version of Kapacitor that will be commercial. Otherwise, your best bet is to start sharding it, right? So have multiple Kapacitor instances and have each of them only take care of a certain portion of your time series data. Looks like I'm out of time. I'm getting the hook.
Thanks, Paul.
All right. Thanks, everyone.